Hi folks, Mr. Dell here. We are going to today explore a little bit more about scale drawing, scale factor, and understanding how to find missing lengths as it pertains to using scale factor and similar figures. So this specifically is a CPM problem from the course 2, CPM CC2, and this is section 4.3.1, and then specifically problem number 4-84. So let's read it together and come up with a solution. So Daniel needed to paint his patio, so he made a scale drawing of it. He knows the width of the patio is 10 feet. So here's the patio, picture of the patio, and 10 feet is the width. But the scale drawing is in inches. So here's his scale drawing. He drew something that showed that that side was 4 inches and this side was 7 inches. So here's our scale. He's got lengths on the scale drawing, but he's missing his length here on the actual patio length, the true patio length. So it wants us to find the length of the patio in feet. We know the width's 10. It wants us to find the feet. So what I know is if it's a scale drawing, it's to scale, there's a scale factor from the actual patio to the drawing, right? This is considered the copy. This is considered the original. So the original is the actual patio, right? The drawing would have been the copy. So he doesn't know what the original length is, but he's got the copy. He's got the scale factor. So he's got the scale drawing. So what we can do is find the scale factor. We know if we think about corresponding sides. So you have to determine what sides are corresponding in order to find a scale factor. On my drawing, this side is corresponding with this side, right? This is the width and the width. So if I can put, when I'm trying to find a scale factor, you always do a ratio of the copy over the original. That'll tell you the scale factor. So I know the copy in this case is 4 inches on top, and then the bottom is 10 feet. Now the problem with me writing 10 feet is then I have inches and feet. So I need it to be the same unit to truly get the right scale factor. So 10 feet as inches would be what? Well, there's 12 inches in a foot. So it's 12 inches times 10 gives me 120 inches. So the 10 feet is actually 120 inches. So it's 4 inches to 120 inches. And then if I simplify that, because both top and bottom can be divided by 4, I would get 1 over 30. So that's my scale factor. So from the original to the copy is 1/30th of the size of the original. Does that make sense? The copy is 1/30th of the size of the original. So now I know my scale factor. I can find my missing side, because if I have 7 inches here, and this was 1/30th of it, right? I can look at it, I can write it this way. I can say 1/30th of X is equal to 7 inches, right? So that's what I need to find, is that X. Well, 1/30th. How do I find that 1/30th? Well, if we're talking about this is 130 times X, when you do of, is equal to 7, I want to figure out what that number needs to be. Well, that would be the opposite operation here. Instead of 1/30th, I could take and multiply by 30 on the other side, right? So 1/30th, the inverse operation is multiplying by 30. So X in this case is equal to 7 times 30, which is 210, and that's in inches. So I know the actual original side, the length of this patio here is now inches. It's 210 inches, but what is that as feet? So as feet, I would need to divide by 12 to get the feet. So take inches, divide by 12. So let's see, what is 210? 210 divided by 12. I'm going to let you do that math. It is 17 and a half. So this is also equal to 17.5 feet. Okay, so there we have it. So let me go back to the answer then. All that to get our answer A. For A, it wanted to know, find the length of the patio in feet. So the length is 17 and a half feet. Okay, B. All right, now B says, find the area of the patio so Daniel knows how much paint to buy. So the area, right? So if our patio now, I'm going to redraw the patio. That's 10 feet by 17 and a half feet, right? Area of this is a rectangle, is just length times width. So area is equal to 10 times 17.5, which is equal to 175. So 175 feet squared, right? Because we're dealing with area. So it's square units, square feet. So that's how much our area is. Okay. And then we go back to the, now part C says 1 can of paint covers 125 square feet. How many cans of paint will Daniel need to buy? Well, if 1 can is 125 feet, so 1 can equals 125 feet squared. I have 175. 1 can is 125 feet squared. I have 175 feet, so 1 can is not going to cover it all. So I'm going to have to buy 2 cans because I'll have some left over. I could say 2.5 cans, but I mean 1.5 cans, but I don't think you can buy a half a can of paint. So he will need 2 cans of paint. Okay, he'll have some left over, but we know he needs to get 2 cans of paint. All right, there you go.